on the same slide.
Because I was thinking maybe it has got stuck.
Yeah. So I think I should move ahead. What I should do is that, first of all, let me point out that till date, there is no model on which there is such. So there are all kinds of models, the most popular models being magnetar flares. Professor Dipankar Bhattacharya has already told you about magnetars and the flares associated with the magnetars, so-called the huge magnetic activities like the magnetic reconnection taking place and releasing huge amount of energy. The other mechanism is due to Falke and Rezola, which is they lose their centrifugal support, because as they are going around, there is magnetic braking, and when they lose the centrifugal support, they collapse, because as Professor Bhattacharya has pointed out, that even neutron stars, they have a critical mass beyond which the neutron degeneracy pressure cannot support the gravitational collapse. And when the rotation rate decreases, no more adequate centrifugal support, and such objects turn into black holes. That is the original Falke, Rezola, and Zhang model. And since the magnetosphere, the pulsars have a huge magnetosphere created because of changing magnetic field due to rotation, causing large electric field that sort of pull apart ions and charged particles from the surface of the neutron star and create magnetosphere. And because of the electric field, electrons are accelerated, radiating gamma photons, which in turn create the electron-positron pairs. This is a whole complex processes. And before the entire neutron star collapses into a black hole, the magnetosphere can radiate radio waves. And the interesting, nice thing about the so-called Blizzard model, this is called the Blizzard model. The nice thing about the Blizzard model is it automatically gives you the millisecond time scale, because 1 over square root of G rho, which is the dynamical time scale of collapse. This also was explained very effectively by Professor Dipankar Bhattacharya. For neutron stars, 1 over square root of G rho is millisecond order time scale. But there are many different kinds of models, as people pointed out, that there are as many different models as people who are working in the field of fast radio bursts. While the interesting thing is that there was a galactic FRB which was detected, and it was coincident with a magnetar SGR 1935 plus 215, that you get a fast radio burst, and after that there was from this magnetar. So there is now a greater, it is a shot in the arm of Metzger's magnetar model for these FRBs. So the magnetar model basically, as was already earlier described by Professor Dipankar Bhattacharya, that from regions where you suddenly develop, just like you have hot spots on the surface of the sun, sudden regions on the surface of the magnetar by itself has huge magnetic field, 10 to the power 15 Gauss, 10 to the 14 to 10 to the power 15 Gauss and more. And if some local region develops an eruption where strongly magnetized plasmoids are thrown out, moving with bulk velocity which is greater than the Lorentz factor can be as high as 40, 50. So they move with ultra relativistic speed and cause shocks. And the in front of the shock, the electrons they undergo synchrotron measures. So basically, you can show by calculating the stimulated coefficient and spontaneous emission coefficient, that it can lead to a major action, and that can give rise to fast radio bursts, while the behind the shock that is coming, they can lead to the X-ray burst. And as I pointed out, the galactic magnetar seem to be supporting, galactic FRB seem to be supporting this model. However, galactic FRB is a very low luminous, low energy FRB and not very high energy FRB. Since I'm running out of time, all I can show is just two more things that we have recently. So this is a artist vision of a magnetar where the magnetic fields are 10 times or 100 times stronger than normal pulsars, and time to time you could have sudden flares from the surface of the magnetar. So the X-rays that are seen are not rotationally powered, but rather powered by magnetic fields getting converted to high energy particles. Right. So one of the things which can be predicted, as shown by Metzger, Fang, and Margalit, is that you could produce energy protons. They can interact with the background photons to create pions, and the pions would decay into neutrinos, and you could produce PeV to PeV neutrinos. And IceCube Neutrino Observatory is looking for them, but however, they have not got a positive detection of neutrinos coincident with 28 fast radio bursts. Similarly, you can ask, do you expect that Blitzar model should also produce neutrinos? The answer is yes, because in the Blitzar model, you have a neutron star collapsing, and in the original Blitzar model, you could have neutron star collapsing into a black hole, but black hole neutron star collapse, the upper bound is about 10⁻50 ergs. While in our earlier work, we had shown that if your magnetar is very rapidly rotating, it cannot form a black hole, because the event horizon of a curved black hole by this quantity, where there is this square root of RS Schwarzschild square minus angular momentum divided by MCU. Rapidly rotating, the square root under the square root sign, you could have a negative quantity and prohibit formation of a black hole. Instead, we had suggested that you could have a strange quark star forming up. And if you make a strange quark star, neutron star forming a strange, then the strange quarks and they can decay quark, and you could produce neutrinos, and you can get out of it. My last slide would be that the observatories, IceCube Neutrino Observatory, Borexino detector, they have the neutrino detection. So by looking at FRBs, and for 28 FRBs that IceCube and also one repeater IceCube had seen, the energy of the fluence of the neutrino is less than about 10⁻³ GeV per centimeter square, while the Borexino, it has produced a bound that, if you consider the galactic FRB, and they have looked at the neutrinos from the galactic FRB, and they have given the constraint that its neutrino energy released in neutrino has to be less than about 5 into 10⁻51 erg. So the question is that, does it mean that we should not be expecting neutrinos from this? The answer is, well, there are, I mean, this is some recent work which we are carrying on, and they could be more powerful available. We looked at the Swinburne data about 118 FRBs, and you can see that there is a hint. If you plot the radio energy as a function of the dispersion measure, you can distinctly see there are there's a two category, the low energy category and high energy category. That time we were not sure, is it a low statistics phenomena? But if you look at the chime also, you'll find that the chime, most of the FRBs are low energy phenomena, this band, while there are still the high energy phenomena. And we seem to be seeing, this seems to be corroborating our older hypothesis that there are two classes of FRBs. So you could have a very small fraction of very high energy FRBs, which might be releasing more neutrinos, but their rates would be very small. I think I should stop, and it's more important that I take questions. So thank you for the patience.
Yeah, thank you, Professor Dasgupta.
So,
this is a one.
Chiranjeev, was I audible? I think
Yeah. You are audible.
You are audible.
Too many things. I stop, and more important that I take questions.
Yes, at this time your connectivity has improved.
I disappear. It's more important that I take questions.
Yeah.
So I think people can ask questions.
Yes. So it is
Otherwise, the audio will
talk.
disappear after some time.
Yes, and I must thank you for giving your time, valuable time to us, and we look forward such kind of cooperation with us.
No, it's
now
my pleasure.
Go to question answer. Someone is asking to Professor Dasgupta, sir, please, sir, theoretically we understand the concept of Hawking radiation as a means of black hole mass reduction. However, there is no experimental evidence for them even after almost 50 years. Why is that? So do you have any answer for this?
Yeah, good question. So the reason is that if you, as Hawking had shown, the Hawking temperature is inversely proportional to the mass of the black hole. And therefore, this was already pointed by numerically, the Hawking temperature of a bin divided by the mass of the black hole in grams. Remember, it is mass of the black hole in grams, 10⁻26 degree Kelvin divided by the mass of the black hole in gram. So a astrophysical black hole, whose mass would be close to 1 solar mass. 1 solar mass is 2 into 10⁻33 gram. Now you calculate what is the Hawking temperature, 10⁻26 degree Kelvin divided by 2 into 10⁻33 gram. It is 0.5 into 10⁻⁻7 degree Kelvin. So such a low temperature object cannot be detected. A black hole at a very high distance having such a low temperature cannot be detected because this temperature is even lower than the cosmic microwave background radiation temperature, which is 2.7 degree Kelvin. So therefore, for astrophysical black holes, you cannot detect the Hawking temperature. Only chance would be if you have a primordial black hole whose mass is so tiny that the temperature is of the order of, let's say, 10⁻7 degree Kelvin, 10⁻8 degree Kelvin, when the Hawking radiation is predominantly in X-rays and gamma rays. So you'll see a sudden burst of X-ray and gamma ray bursts. In the earlier time, some of the models for gamma ray bursts was this exploding primordial black holes, but it is untenable because of various other observational constraints. So I hope I have answered your question. Only if you create a very tiny black hole in your large hadronic collider. In fact, one of the early aim of having large hadronic collider is to produce black holes, because there is a extra large dimension theory where you can still produce black holes using 10 TeV energy scale. So if you can produce a black hole, tiny black hole in the large hadronic collider, you can test the Hawking radiation.
Okay, so next question is, although dark matter is so prominently present in the galaxy and marks up to 95% of the universal mass, why is it that its detection rate is in the order of 10 power minus 5 to 10 power minus 9, depending upon mass?
You're talking about dark matter or dark energy?
He's talking about dark matter.
Yeah, but dark matter
Yeah.
is not 95%, but rather, as you know, the composition is 5% standard matter, which we are made out of, and rest of the 95%, about 27 to 29% is dark matter, and rest, the dominant component is dark energy. Yeah, so coming to dark matter particles by very nature, the dominant interaction they participate is gravitational, and that's how they were detected indirectly. But the fact that they do not interact with photons or do not interact with protons, neutrons, or electrons means their interaction has to be either weak interaction or less than weak interaction. So gravity and an interaction whose strength is less than weak interaction is what they interact with. And therefore, detection of dark matter particle is experimentally very, very challenging. And the xenon detectors, etc., they have put stringent bounds on the dark matter particle, and the original idea that cold dark matter particle inspired by supersymmetric particles would be about 100 GeV to 1 TeV rest mass with interaction cross section close to weak interaction cross section. That has been ruled out. Now the bounds are bigger, so you need 100 TeV WIMP-like particle and with even less interaction cross section, and therefore it is no longer attractive to the supersymmetric models. So indeed, cold dark matter particles are currently facing severe challenge, and slowly people are drifting towards ultra light dark matter particles of the kind of axions whose rest mass is either 10 to the power minus 20 electron volt or even less. So the upshot of all these is that we still do not have any knowledge, proper knowledge of what the dark matter particles are really.
Okay, so Smitorshi Roy is asking, sir, can FRBs be used for measuring the rate of expansion of the universe?
Yes, correct. That's a good question.
And can you briefly explain what magnetars are? These are the two questions.
Yeah, yeah. So of course, the expert of magnetar is right here, Professor Dipankar. But basically, magnetar is also a neutron star, but having magnetic field from 10 to the power 14 Gauss upwards. So it can't, of course, exceed 10 to the power 16 Gauss, because there is a limit coming from Schwinger's model of magnetic field producing particles from vacuum. So there is a instability created from quantum process. So magnetars are those neutron stars with magnetic field more than 10 to the power 14 Gauss, and can be somewhat more than 10 to the power 15 Gauss. And these are not rotating as fast as the typical pulsars. They are slow rotating neutron stars, 10 seconds, 100 seconds, and so on. And time to time, I mean, as you know, magnetas were discovered from sporadic X-ray emission from many galactic source. And so it turned out that unlike the case of pulsars, that the pulsar, whether many of the pulsars, of course, are radio pulsars, but there is a handful of pulsars which emit optical X-rays, gamma rays, like Crab pulsar or Vela pulsar. And in the case of pulsars, because the magnetic fields, the pulsars are rotating very fast, so there is a magnetic braking. Since if you take a non-aligned rotator, magnetic field having an angle with respect to the spin axis, you can see that as the magnetic field lines precess, they create a huge amount of magnetic dipole radiation that carry away rotational energy of the pulsar, and the pulsar slows down. And the slowing down of pulsar has been quantitatively measured by monitoring the period of the pulses, the pulse between two successive pulses, what the period is. This period actually increases, but at a slow rate, 10 is for minus 18 second per second, that kind of slow rate. And but the fact is, the pulsars slow down due to magnetic braking, while the X-ray emission from the magnetar, people realize that this is not causing any slowdown of the magnetar. So therefore, what powers the magnetars? And it turned out that around 1999 or so, people were convinced that the X-ray release from the magnetar is largely due to the magnetic process. Density with magnetic field B is B squared by 8 pi. And when B is 10 to the 15 Gauss within, let's say, light cylinder length scale, the amount of magnetic energy is huge. And therefore, you could produce sudden burst of very high energy particles from the conversion of the magnetic energy. Such conversion is there, magnetic reconnection, which is a way Professor Dipankar had mentioned about it, where magnetic lines, one moving in one direction, other moving in another direction, when they come together, they give rise to burst of energy in charged particles, which are evidently radiated. And this is the common explanation for solar flares. And so these are the things which cause the X-ray outburst from magnetars. I hope I have answered your question. Regarding your first question, that whether FRBs can be used to study cosmology, the answer is yes, because far away FRBs, they tell us a lot about the intervening intergalactic medium from the dispersion measure, and therefore one can study one can put limits on the density, number density of electrons in the IgM, and also from that one can have limits on the kind of baryonic matter, known matter, and therefore one can do a lot of cosmology with it. The question is whether you could measure the Hubble parameter. The answer is that you can't do that with greater accuracy, because only if you have FRBs that act as standard candle, like what Professor Dipankar Bhattacharya mentioned about type 1a supernovae, which more or less act like standard candle. One has not discovered a standard candle FRB, meaning thereby that a class of FRBs whose total energy released in radio is constant within a small margin, or luminosity, radio luminosity being constant within a narrow margin. If such radio bursts are discovered, then one can measure the Hubble parameter with it. As you know, there is a tension, Hubble tension, that cosmic background radiation give us the Hubble parameter to be close to 68 kilometers per second per megaparsec, while the Rice et al., the Nobel laureate Rice et al., their group, when they look at the Hubble parameter measured from galaxies, it turns out to be close to 72 kilometers per second per megaparsec. The question is whether is the errors which is causing this tension, or whether there's something fundamental, some fundamental physics which is going wrong in the CMB analysis. One doesn't know currently, but it's a very exciting phase for cosmology.
Okay, so we cannot go on asking so many questions. We have to stop here because of the paucity of time. So let me thank once again Professor Patrick Dasgupta.
Most welcome.
And now we will go over to the next speaker. Our next speaker is Professor Suresh Chandra from here. And the title of his talk is Challenges and Opportunities in Astronomy Astrophysics and Astronomy Astrophysics versus Astrology. Now, Professor Suresh Chandra would be introduced by Dr. Gautam Singh. So it's over to you, Dr. Singh.
Okay, thank you, Kunal sir. So hello everyone, it's my great privilege to introduce Professor Suresh Chandra to you all. Chandra sir is Deputy Director and Professor at MIT Center for Astronomy and Astrophysics at MIT University, Uttar Pradesh, Noida. After passing all examinations with first division, he did his PhD in physics from Meerut University, Meerut. He is a fellow of Royal Astronomical Society, London, fellow of Alexander von Humboldt Foundation, Germany, associate member of Third World Academy of Sciences, Italy, fellow of Maharashtra Academy of Sciences, Pune. He was the director of the School of Physical Sciences, SRTM University, Nanded, Maharashtra, director and dean in Sri Mata Vaishno Devi University, Katra, Jammu and Kashmir, head of physics department in LPU, Punjab. He has 50 years of teaching and research experience. His field of research includes molecules in interstellar medium and solar plasma. He has worked in foreign universities for 7 years as a Humboldt Fellow of Germany, visiting scientist in DFG project in Germany, guest of USSR Academy of Sciences, and as a visiting scientist for 12 times under Scientific Exchange Program of INSA, New Delhi, and under a revisit program of Humboldt Foundation. He has been visiting associate of IUCAA Pune for 32 years, visiting associate of UGC New Delhi, associate of PRL Ahmedabad. He has completed 15 research projects supported by UGC, DST, CSR, ISRO, and UP State of Council of Science and Technology, Lucknow. And one project is still ongoing, funded by ISRO, Bangalore. He has guided 11 PhD students and 2 MPhil students also. He is a life member of 15 academic associations bodies in India as well as abroad. He has written 20 textbooks. One of them is supported by the National Book Trust of India, and one is published by the NCERT New Delhi. He has published over 173 papers in the journals of repute. Out of them, 19 are published with foreign scientists. He has published 32 scientific articles in reputed scientific magazines, published 8 articles pertaining to higher education, and 1 chapter in the 2 reference books. With these words, I would like to invite Chandra sir to deliver his lecture. It's over to you, sir. Thank you.
Thank you, Professor Gautam Singh, for giving my very extended introduction. My slides are visible or not?
Yes, sir, it's visible. Please make it full screen.
Okay, I am making it full screen.
Yeah, it's good. Okay, please go ahead. Yes, sir.
Let me prove it. Why it is coming? Why it is not coming complete? It is going up. Why it is? I don't know. The slide is going up.
But here we can see properly.
No, we can see properly. There's some small thing will be there in the top, but that doesn't prevent from displaying.
My topic is coming challenges, full challenges or not. But here some strip is there. New slide, new share, something is coming here. I don't know why it is there.
Sir, can you please unshare and then again share?
Unshare, how to unshare? It's not here. Unshare, new slide is here. Out. And Dr. Konar.
हाँ बोलिए। अच्छा मैं आता हूँ।
आइए देखिए अनशेयर ये my slides are going up. Slide is going up. हाँ ये देखिए देखिए ये स्लाइड ऊपर जा रही है मतलब कंप्लीटली कट जा रही है। इसको नीचे डाल दीजिए और नीचे ले जाइए। कहाँ जाएगा? नहीं ऊपर स्लाइड कट रही ना, स्लाइड दबा रहा है ये। नहीं वैनिश नहीं हो रहा ना। शेयर भी आ रहा है यहाँ, शेयर यहाँ पे न्यू आ रहा है। And Dr. Gautam Singh is saying that you just unshare and again share. It's not coming. It is coming new share. Share is coming again here. So many shares. Yeah. But again it is cutting. Okay, screen sharing stopped as it. Share is here, okay. Share the screen, okay. So okay, give the okay, and then make full slide. I don't know. Make it full slide here. No, again it has gone up. So it should be half. So it should be like this. Will it work?
I think Kunal sir, can you instead of putting full screen, if you can increase the size of the slide here and then if you can speak.
Yeah, no, full screen is giving problem.
No, I'm saying that instead of
This
making
one.
full screen, just and slightly increase the size here.
Yeah, okay.
Yeah.
Thank you, ma'am, very much, Dr. Gautam Singh, for your giving me very good introduction. So first, I must thank the organizers to give me this chance to speak about the challenges, opportunities in astronomy, astrophysics, and astronomy versus astrology. Okay. I will start from the scratch. Which phenomena would have been seen by the people first without any efforts? For example, they would have seen the rising of sun, setting of sun. They would have seen that after the sun sets in the sky, there are stars, large number of stars are there. And then there is the moon, the size and the position of the moon among the stars is changing every day. We call them phases of moon. They might have seen the solar eclipse, lunar eclipse, and the comets. All these would have been seen. My question is whether scientists have put some efforts to see them. I will say no. What is the reason? That I cannot go with the slides going on. So my point is why human could not remain ignorant about these natural phenomena. The point has been that every human has the eye, which is a natural one of the senses given to the person, and the Earth's atmosphere was transparent for the electromagnetic spectrum in the part which the eyes can see. So these two phenomena, that eyes, human has the eyes, and the electron at the Earth's atmosphere is transparent for the electromagnetic radiation in the visible range. So these does not allow the human to remain ignorant. I have to shorten, but I wanted to put one question to the students because there are students, some students I have explained this question and those can answer, and for others, suppose we go around. I always put in my class some questions, and one of them is this. Then for if r is the radius, then the circumference of this is 2 pi r, and the angle subtended becomes the arc upon radius. 2 pi r upon r is equal to 2 pi radian. But we say that when we go around, this is 360 degree. From where this 360 has come? Please put your efforts and write me if you want to get the answer, or in the end, if the time permits, I will answer this question. From where this 360 figure has come, that we go around and then we say that this is the 360 degree. Okay, before going to challenges, I would like to say that what has been understood already, there are so many phenomena which have been understood already, and some of them I have written here. One complete lecture can be on these phenomena, how these phenomena have been understood by the scientists in the beginning. For example, day and night on the surface of the earth, how this is explained. And if the slide can go, let me try to see that if I lose some point, then it is better. And some will go vibration, variation of the length of the day, that the length of the day is varying. Day means the bright time and night means the dark time. How this is changing in this summertime in our area in the northern hemisphere, the day is longer than the winter time. How it has been explained. Stars in various nights are changing. They are not the same. If you see, for example, after 6 months in the December and you see in the June, the stars are completely different. They are not the same stars. So how it has been explained, and if we look all these phenomena, one complete lecture can be given. How the phases of the moon were understood, how the seasons on the earth were explained in terms of the how they are changing. We have the summer, we have winter, we have different seasons changing, and how they are changing on the earth. How the shape of the earth, for example, in the morning I mentioned that one student asked me that we are living on the surface of the earth, and earth appears as a flat. How the spherical shape of the earth was obtained, and this was obtained about 2500 years ago when the technology was not advanced. So how the shape of the earth is obtained, how the size of the earth was obtained. All these phenomena we have understood already, so I am mentioning here one by one. Distances of the sun and the moon. This was a big discovery that the sun and moon around the earth are not moving in the same hemisphere, on the same sphere, but they have a distance. It means the discovery has shown that the sky has a depth. They are not at the same distance. The moon is closer to the earth as compared to the sun. It was found. Sizes of the moon and sun, how the sizes of the moon and sun were decided, though it was a very rough idea in the past, and now it has refined. Now we have refined values, but how this was done about 2500 years or maybe 2500 years ago is a complete lecture to be given to the students, and they will understand how the solar eclipse was explained, how the lunar eclipse was explained, and the tides on the surface of the earth were understood, how the sources of energy of the sun, how the sun is shining. You are listening from the morning that the sun has a working, the nuclear reactions are going on in the core of the sun, and several lectures have been given how the hydrogen is converted into helium, helium is converted into heavier elements, and we have gone up to the iron. In one lecture, it was given by Professor Das, how the life exists on the surface of the earth. It has been understood. What is the cause the life is existing on the surface of the earth? Retrograde motion, how the retrograde motions of the Mars and Jupiter and Saturn have been understood. Comets have been understood. Meteors, what is the meteors? And the very important aspect is the duration of the solar eclipse is changing with time. At present, the solar eclipse is taking place for the couple of minutes. But if we go in the past, it was taking place for several hours. And in the time of the Maharashtra, we have a complete story about the Jayadratha Vad. Jayadratha was killed, and at that time was the total solar eclipse, and duration of that solar eclipse was very large. And if it is going on decreasing, then in future we will not have this total solar eclipse. All these phenomena and many more phenomena have been understood, and there can be one complete lecture how these phenomena have been understood. After that, there are many phenomena in which are the challenges, which remain the challenges. I don't know how this point to remove, and this is giving some challenges in astronomy and astrophysics. I brought it down, and if it is needed, there are many things which are giving the challenges, and if any of the challenge can be explained, one can get very high award, definitely. So I have just given here a couple of challenges. What is happening? It stopped sharing. It stopped sharing.
Chandra sir, please share again.
I am sharing again.
Yes, yes.
Yes. And trying to,
Yes, it has come.
yeah, it has come. Some challenges in astronomy, astrophysics now is better. And the first challenge, we are using the law of gravitation. Here is the photo of the Einstein. Sorry, photo of the Newton. And there are stories that the apple fell on this head of the Newton, and this gave the birth to the law of gravitation. And many scientists are working in the field of the relativity, general relativity, and they are trying what is the cause of the gravitation. The cause of the gravitation has not been understood so far. It is a big challenge for the scientists working in astronomy, astrophysics. I have taken, and another, I have put to find the source, search for the extraterrestrial intelligence, that we are thinking that there may be life in the universe other than the surface of the earth. So to understand that, very first point is the why life exists on the surface of the earth. I have tried to answer that the atmosphere of the earth is consists of the nitrogen, oxygen mainly, and some noble gases. Nitrogen is large so that it is not burning, and oxygen is very small. And this atmosphere is supporting the existence of the life. And it is giving that the life can be produced, supported on the surface of the earth. And with the idea that there are so many stars, and some stars may have the planets, and some of the planets on the stars may be at such advantageous position as our earth. And therefore the people are trying to find out the exoplanets, planets around the other stars. These are the exoplanets, and so far, as I have taken the data, and it is increasing day by day. On 1st October 2022, 5,197 confirmed exoplanets are there. But still we have not found the life on any of the exoplanets, and people are trying to find out the exoplanets. They are very distant objects. So this is first point to be discussed. I don't know what is giving this point. Big problem. Stop share, again it is saying stop share. If I stop share, please share, pause share, stop share. What is coming this?
We can see your slide actually, sir.
No, but slide is not moving anymore. Sir, slide is not moving anymore. It is saying pause share, stop share, new share. What is it? Is in my laptop, or it is coming from the what to do? It has stopped. It has stopped sharing. It is not going anymore.
I think, sir, we don't have other choice except again sharing and all that.
So it will stop sharing. Yeah, stop share करते हैं तो फिर से Okay, let me try to say something, if I can do the gravitation, and then we have gone for search of the life on the in the universe, that is the SETI, to answer whether we are alone on the surface of the earth. And third, I have taken the challenge to explain the coronal temperature at the time of the solar eclipse. The sun is there shown, this is covered, and in this region we call the corona. In this region, two lines, very bright lines, were obtained at the wavelength of the 5,303 angstrom and 6374 angstrom. Two lines were very bright, and people tried to understand these lines and could not find any solution. They thought that the temperature of the photosphere is about 6,000 Kelvin. So the temperature are in the corona may be less than or equal to 6,000 Kelvin, and they tried to produce the elements or singly ionized ions, and they could not find from the any element these lines, and they tried to say that these lines would have been created by the coronium, some new element, but people wanted to know what are the characteristics of the coronium. If that is producing these lines, what are the characteristics, and they could not understand. But scientists went on increasing the temperature in the laboratories, and B. Edlin in 1940 found that these two lines can be produced by Fe14 and Fe10. Fe14 means 13 times ionized iron and 9 times iron. And these ions can be produced at very high temperature of million Kelvin. It means the temperature in this region in million Kelvin. If there is very high temperature, one point is how this temperature is produced, and another point is how it is going on, how it is persisting, because high temperature will give the radiations, will radiate the electromagnetic radiation in, and if there is any atmosphere, then the conduction will take place, so the temperature must decrease, and this temperature is going on continuously. This is going continuously for very long time, and scientists are not in a position to explain how this temperature, high temperature of the corona is being maintained. And many theories are being given, but no explanation, correct explanation for this has come. Then I tried to understand, people are trying to understand the size of the universe. How big is universe? It has been discussed that the universe was created about 13.8 billion years ago through the Big Bang. And at present, this is estimated that the size of the universe is about 93 billion light years. And here I have given the estimate of the light year. 1 light year is equal to 9.47 10 to the power 15 meter. If you can understand how big is the universe, then the question comes how to get the complete size of the universe. To understand, I would like to that in the morning, this Carl Jansky discovered that the radiations in the long wavelength can also come to the surface of the earth. And in the lecture of Professor Gupta, it was mentioned that we have two windows. One is the optical window in which probably the radiations visible to us are coming, and second is very wide. This is the radio window. So in the radio window, the radiations can come. So we got the two windows after the discovery made by Carl Jansky in 1932, that we have radio window and we have optical window. Then question came, which window is more important? So if I don't want to give the importance, if we go to see the phenomena, then this can be seen only through the optical window, and we cannot see through the radio window. And on the other side, if we see the ratio of the wavelength in the radio window to the optical window, it comes out 10 to the power 5. This may not be visible, I am sorry, because this some technical problem is there. Let me try to make it again, if it can go. It's a little bit bigger. So the wavelength in the radio window to the wavelength is optical window, it comes out about 10 to the power 5. And if we take the formula that scattering is proportional to the 1 upon lambda to the power 4, then the scattering in radio window to the scattering in optical window is about 10 to the power minus 20. It means the radiations produced in the radio window reach the surface of the earth without loss, much loss, very little loss is there. I have been asked to have the time very minimum as possible. So what are the source? The source for creating the radio lines are the molecules. Molecules, we study that we have electronic labels. In the electronics, we have vibrational labels, and in the vibrational labels, we have the rotational labels. And the transition between the rotational labels produce the radiations in the radio window. Hence, if in any part of the universe we can find the molecules, then they can send the information, very valuable information, to the surface of the earth. So we are thinking that one of the means to go to the boundary of the universe can be finding the hello hello, some sound is coming. So we have to find the molecules, and the molecules can play important role. This is the field of my research also. And the scientists are hoping that the radio window can be used for getting the information about. Another challenge, it is coming very well, is to find the impetus. This is a satellite, natural satellite of the Saturn, and half of the impetus is dark, black shaped, and half is bright shaped. How this kind of the satellite can be developed? So this has here another point is the magnetic field in the solar atmosphere. We are discussing about the magnetic field. It is again stopping. We have to put it here. Okay. So sun's magnetic field is very challenged that it flips after 11 years. The sun's magnetic field is like a dipole field, bar magnet field. And after 11 years, the north poles becomes the south pole, and south pole becomes the north pole. And this is a big, very big challenge when scientists are working on this field, but could not find. The magnetic field was observed in terms of the sunspots. Picture of the sun, one sunspot where we have the dark portion, umbra, and outer portion, penumbra. The sunspots are formed. And the interesting point that if we see that this is the diagram, this is the time, this is given the number of sunspots, here's the equator. Sun has the equator, and on the side, the sunspots are formed. And this is giving the 11-year cycle. But sunspots are formed up to the 40 degrees on the north side and 40 degrees on the south side. And this all challenges are coming in terms of the magnetic field of the sun. How this magnetic field of the sun is changing, flipping after 11 years. That before the new cycle starts, they start from the large degree and come near to the equator. And then before ending of the cycle, the new cycle starts, this magnetic field flips after 11 years. This is a big challenge, and this can be solved if anyone is there. Here I cannot see astronomy. Opportunities in astronomy, astrophysics. What are the opportunities? In the morning, Dr. Gupta had discussed that how you can go for the study of the astronomy, astrophysics, but point is that okay, this can go. In India, we have limited institutions where the astronomy, astrophysics as a subject is being taught. But astronomy, astrophysics has large opportunities. Large number of students are choosing their career in astronomy, astrophysics, and going to work, and they are working already in this field. In India, large number of institutions are teaching astronomy, astrophysics as a part of the physics and mathematics or mathematics. For example, in Amity University, we are teaching some courses of astronomy, some papers of astronomy, astrophysics with physics. And in one time, at one place in Lucknow University, they are teaching with mathematics. In Nanded, they are teaching with physics. In Gorakhpur, where I have been, they are teaching with physics. So after getting their training in astronomy, astrophysics, the students are going abroad for doing either job or for doing PhD. And they are going abroad. There are many universities, for example, in Germany, in France, in Austria, where I know my students have gone in USA, where they are giving the full financial support for doing PhD in astronomy, astrophysics. If my students can go, nowadays the Nobel Prize, even the astronomy, astrophysics are being given. Now it is a part of the physics. And if we see for the last 21 years, about 7 Nobel Prize have gone to astrophysics, while the physics has so many sections: atomic physics, we have the solid state physics, neutrino physics, so many are going, so many neutrino solutions. And these are the 7 years where the Nobel Prize has gone in astronomy, astrophysics. So this is about the opportunities, and I wanted to come to the next point, which is the astronomy and astrology. At this point, I would like to take some minutes that whenever we are getting the questions about the astrology, we are trying to explain to the persons that astrology is also a kind of the positions of the celestial bodies. But astronomy, astrophysics is also a kind of the celestial bodies. Then they say, ask, what is the difference? We always say that astronomy, astrophysics does not say what will be the effect of the positions of the celestial bodies on the human being. But astrology says that it will affect, because astrology is deeply rooted in the life of the people, at least in India. Right from the birth of the child, we go for the namkaran to the Panditji. We say that child is born, please give the name or come for the some havan or like this. And the puja, there may be Holika Dahan, then we ask the proper time from the Panditji, Deepavali puja. Now Navgraha Shanti, we always ask for the Navgraha Shanti. Sir, Navgraha Shanti is always in every puja. Havan engagement also we go asking the which time will be auspicious, which will be better time, Shubh Mahut, Panditji will saying. And if there is ring ceremony, we consult the Panditji. Always we are going to the astrologers, marriage ceremony. And if somebody is filing the papers for nomination as a chief minister, as a MLA, they ask the Panditji, which will be the auspicious time for the election, and if they are elected, which will be the auspicious time for taking the oath ceremony, and many more. You can say that there are many phenomena related to our life where we are consulting the Panditji. It means we are going to the astrologers. But what is the astrology? I will try to tell in couple of minutes. Before proceeding, I will say that I will not go in any dispute whether the astronomy, astrophysics is right or astrology is right. Hello?
Sir, can you finish in 5 minutes?
I will try to finish in 5 minutes. Okay.
Okay.
I will try to finish in 5 minutes, but let me try to tell something. Okay.
Okay. Yes. Yes.
Okay. Before 24th August 2006, we had 9 planets. And by the way, we had 9 graha. So we were saying that 9 graha people were considering are same as 9 planets. But there is no one-to-one correspondence between the 9 graha and 9 planets, right? So let me say, now we say that we have 8 planets. Then people ask Panditji, which graha is no more? Which graha, kaun sa graha shant ho gaya hai? Which graha is now peaceful? Tell me. So there are now 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. and now Pluto is no more the planet. This is also a very good question. Why? So for understanding this, what is a planet? Planet is a body revolving around a sun having more than the specific size. And this value of the specific size is decided by International Astronomical Union. Before 24th August 2006, this value of the specific size was the size of the Pluto. And therefore, there was no problem if other body, smaller size were discovered, then the Pluto was in the list of the planets. But one fine morning, they have found the Eric, and the size of the Pluto is here. Other bodies which were discovered, the size was smaller than the Pluto, and the Eric was discovered, and the size of the Eric was more than the size of the Pluto. Then the question before the International Astronomical Union was that either to change the value of the specific size so that Eric is not included as a planet, otherwise we have to include Eric as the 10th planet. So on 24th August 2006, the Astronomical Union changed the value of the specific size more than the size of the Pluto. More than the more than the size of the Eric, so that Pluto is also excluded from the list of the planets. And now we have 8 planets, but still we have no Grah. And we asked Panditji which Grah is already peaceful now. We have not to go for Navgrah Shanti. But let me explain 5 minutes time that this whatever the 8 planets are going on, they are based on the heliocentric system. In the heliocentric system, we have Sun at the center, and the Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto are revolving. But I have given here up to Saturn because at the time when the idea of this heliocentric system was given in 1543 AD, we did not know beyond the Saturn, up to Saturn. Then I come to the astrology. Astrology is based on the geocentric system, not the heliocentric system, where the Earth is at the center. And it was decided that the Earth is supreme long back. And up to now in the astrology, we are using the geocentric system where Earth is at the system, at the center. And at that time, it was decided that no body will revolve around any other body other than the Earth. Every body will revolve around the Earth. Even there are the Sun, Mercury, and Venus. They were discovered. Then it was decided that they are revolving around the Earth as one identity. And they did not say anything how the Earth, Sun, Mercury, and Venus were having the arrangement. So in this astrology, we have the Earth at the center. In astronomy, we have Sun at the center. So this system remains valid, and still it is valid in astronomy. Astrology, it is still valid. So we are depending on the geocentric system. Then the point is, what are these 9 Grah? So 7 Grah are according to the days of the week: Sunday, Monday, Chandra; Tuesday, Wednesday, Thursday, Friday, Saturday, Sunny. So 7 Grah are according to the days, and there are 2 more Grah, Rahu and Ketu. And question is, what are the Rahu and Ketu? These Rahu and Ketu are called the shadow Grah because they are coming from the intersection of the moon and the sun. What are these? These are the depending on the ascending node, and these are the descending node. Because I have to go hurriedly, I cannot go in detail of this. Earth is at the center. Sun apparently red path is going around the Earth, and the moon blue path is going around the earth, and their orbits cross. At this point, it is called the ascending node, and at this point, it is called the descending node. And these two nodes, they are basically the lines. They are basically the lines of intersection of two planes, and they are called the Rahu and Ketu. 9 Grah, these are the Rahu and Ketu, and there is no correspondence between the planets and the Grah. Okay, let me go further, leaving it. Whenever we see the symbol, we always say, okay, this is astrology. Whenever we say these are the 12 parts, and we call these 12 positions. And what are these positions? If we look, these are the angles between the orbits of the sun moving around the earth, and this is the moon, which is making the subtending the angle of 7 degrees, 5 degrees, and this is Mars, and the largest is the Mercury, 7 degrees. It means all of them are moving around a very narrow strip around the earth. And if we go further, this region around the earth is here, and all these planets are revolving around the earth, and this region is 360 degrees. I have said that they are divided into 12 equal parts, 1, 2, 3, 4, 5, and 12. And they are the Grah, they are the positions. They are the 12 positions which are seen in the Kundali. These are the 12 positions which are seen in the Kundali. So these are positions, and here you can understand that at this point is the earth, and these Grah going around the earth at one time. For example, Grah is here. If it is seen from the earth, the projection will be going in the position 12. If it is here, this is going in the 12. So we say that at some time, some Grah will be in some other position. So they are showing in the Kundali. So these 12 positions are given the names of the Rasis or zodiac signs. Rasi, I have written Mesh, Vrishab, Mithun, Karak, Singh, Kanya, Tula in Hindi. And here is the Aries, English name, Aries, Taurus, Gemini, Cancer, Leo, Virgo, and so on. It means we have these 12 Rasis, 12 positions around the earth, and we have 7 Grah, and at some time the Grah will have the position. So here I have given what are the time periods in which time, how much time they go around the earth. Surya goes in 365.25 days, and in 30 days it will go about 29 and 57, about 30 degrees. It means in one month, 30 days, the position of the sun will change by one position to other position. And they have given, I cannot go in detail. And here I will point out that the sunny is going in 30 days only 1 degree. It means sunny goes very slow. So it sometimes take about 29.5. Yes, I'm completing. So at some time they are going to complete, and here are the 12 positions. And at one time I have given the positions on 19th May 2002. I have taken the position, what will be positions. These are 12 positions, and these are the positions. For example, Ketu is in 6th position, Rahu is in 12th position, both are going in retrograde motion. So this explains that if we go for the positions of these celestial bodies around the earth, they are the same as we have the positions of the planets going around the sun. If we make the transformation, they are the same. So there is no difference up to this stage between the astrology and astronomy. But after that, the astronomy says that there will be no effect on the life of the human being due to different positions of the celestial bodies. But astrology says that there will be effect. So we don't go in that discussion. And at this stage, I have got the signal to stop the discussion. Thank you very much. If you have any questions, you can send me the email. The emails are already published, so I stop the discussion. Thank you very much. Again, thanks to the organizers to give me the chance. Thank you very much. Hello.
Yes, sir. Thank you so much, sir, for your nice presentation.
Okay.
Thank you so much,
thank you.
Professor Chandra, for nice presentation and clarifying the difference between astrology and astronomy.
Yeah. Okay.
And now there are some.
The
So
last-
someone is asking, Rahu, Ketu always are retrograde motion, showing retrograde motion.
Yes, they are always in retrograde motion because they are the projections, they are the intersection points, and they are always in retrograde motion.
Yes.
And the difference between them is the six spaces. If the Rahu is in first place, then the Ketu will be in the 7th place. They are
Yes.
opposite to each other.
Yeah.
Yeah.
Yeah, it is good to work out with Kepler's equations or even using Kepler's
Yes.
Newton's gravitational law, and to find out the
No, point will come to use the these equations. You have to use the solar system.
Yeah, that will be very interesting exercise, mathematical exercise for
Yes. You have to go to the
physicists and mathematics.
But if you want to go with the astrology, you have to use the geocentric system. Right?
Yeah.
Okay. If there are questions, you can forward me. I will answer through the email.
Okay.
Okay.
So now let me see.
How to? I am not sharing. How to unshare is not giving me. Right.
One question, just please take. Then we'll
Yes.
stop. How can one predict future of anyone using astrology?
Oh, that I said that we don't believe that there is any impact on the life due to the positions.
Yeah.
And that is the astrology.
Yeah.
And I have to go up to the positions of the celestial bodies with respect to Earth or with respect to Sun. If we go with respect to Sun, this is the astronomy, astrophysics. And if we go with respect to the Earth, it is the astrology. After having the positions, we don't go further. We cannot predict the future. Okay.
Yes, we should have clarified that.
Yeah.
Okay. Thank you, Professor Chandra, for nice
Thank
talk
you.
and pointing out the difference between these two things. And now we will close this afternoon session, but now valedictory will start. And session chair is Dr. Gagan Sharma. So I'm handing over to him. Dr. Sharma, please.
Okay, good evening, everyone. This is Dr. Gagan. And sincere thanks to all the organizers for giving me an opportunity to chair this valedictory session. So it is difficult to end an event where there is a flow of knowledge from such eminent speakers. And in fact, from both sides, as the number of interesting questions were asked by the attendees, including students.
Gagan sir, just 1 minute. I will just announce it to the participants that please do not go away. We have a quiz number 2, and that you have to score certain marks in order to get the certificate. So please wait for the quiz number 2. So at the end of this session, we will give you the quiz link. Please carry on, Dr. Gagan.
Okay, sir. So today we had deep insights into several issues of astrophysics, summary of which will be introduced by Dr. Konar subsequently. So moving ahead in this valedictory session, it's my pleasure to invite Dr. Ashok sir, Head of Physics Department, whose directions, accurate planning and timely execution helped us for the successful organization of the workshop. What do you say?
Thank you. Thank you very much, Dr. Gagan. And I'm immensely grateful to all the speakers for such wonderful lectures. And I'm sure that my students really got enriched with their career opportunities, what they were seeking. Even during the admission time, we had very direct questions that what are your initiatives towards astrophysics and astronomy? We are interested in that. And when I was getting slightly into the deeper conversation, I could gauge that it's not mere interest. They are not only the sky gazers or watching it through telescope. The technology has given them a real freedom to even watch the live telecast of James Webb's telescope. And that was really surprising. And then we had a very healthy discussion with our faculty members that we should do. And since we had expertise available in our own department, we took this initiative to go ahead with at least one-day workshop to encourage our students and prepare them for their future career. So I hope they will, they must have got enriched, because everything was discussed from fast radio bursts, gamma ray, and LIGO, and all sort of things. All the aspects were covered. I won't take much time. Dr. Konar will be anyway summarizing this, but I think it is a very great good start. But we must, as a department, we must not lose the momentum. We should go ahead with a full-fledged, rigorous conference on the subject, including the tutorial segments. What is the need? Students have already emphasized, and we will be taking looking into all those aspects. So, without taking much time, I would like to thank all the speakers, all the people involved in making this event a great success. Thank you. Over to you, Gagan sir.
Thank you, sir, for your kind words. Now it's my immense pleasure to invite the core inspiration of this workshop, Professor Sunita Ratan ma'am, who is Dean of Faculty of Science and Technology, as well as the Director of MIT Institute of Applied Sciences. Over to you, ma'am, please.
Thank you. Thank you, Gagan sir. I think I must first of all congratulate each and every participant for giving us the chance to explain whatever were your queries. All the speakers have done an excellent job, and I think they kept all the audience glued to the online, because we have seen that in online the students and the faculty members, they tend to go away sometimes, but here I could see the students were glued to their some mobiles whenever they were hearing the lectures. They were sitting there asking the questions. So congratulations to all, and I would like express my deep sense of gratitude to all the speakers. Their talks were simply excellent, and we really look forward to call each and every speaker to our institute so that physically we can gain, because we have heard them online, but it will be a great experience, and it will be a privilege to call them to our institute so that we can gain more from them. And I think astronomy and astrophysics, the mysteries of astronomy and astrophysics are yet to be explored. There is much what has been already explored. So it's a field where the students are interested, and incidentally, at MIT Institute of Applied Sciences and at the physics department, we've got very good and great team under the guidance of Dr. Suresh Chandra and Dr. Chiranjeev Konar. Both of them are very hardworking, and I think they have done this very nicely. It was organized in a very short time, but the scale and the quality of this workshop does not say that it is in a very short time they have done such a good work. So congratulations, and I would like to congratulate Dr. Ashok Kumar and his team for the execution and the smooth execution of the whole program. So thank you all. The whole team, I think all the session in charges have done wonderful work, though I know, because I was discussing behind the scenes, that we had given them this responsibility in a very short duration, but they could prepare it whether it is an inaugural program, whether it is a valedictory program, or in the sessions. Everyone has done a beautiful and wonderful job. So congratulations all, and we look forward for such type of workshops in the future also. And this is my last comment to the students and the faculty members who have joined, that don't let this to be the closing of the workshop. Let it be the beginning of the era. Let it be the beginning of new ideas and new research collaborations in astronomy and astrophysics. Let that thinking now take a flight, so that you can go and explore the mysteries of astronomy and astrophysics, and you should see that this workshop can be a turning point in your career. Like, you have this workshop, you have seen all the lectures, you have heard all the lectures, and if you have passion for astronomy, then I think this workshop will be really a milestone in your career. So all the best. And I think the outcome of this workshop should be more workshops in future, so that students and faculty can benefit. Congratulations to all the physics department and the team and astronomy and Center for Astronomy and Astrophysics. Congratulations. Thank you.
Thank you, madam.
Thank you, ma'am.
very much,
Thank you.
ma'am.
Thank you, ma'am. Your words and admiration motivates us to work even harder. Before moving ahead, since we are limited with the time, so I would like to thank our fellow coordinators, Dr. Kavita Sharma, as well as Dr. Devrati Roy, for managing the schedule of this event, specifically of this session. Now I would like to invite Dr. Chiranjeev Konar, who is backbone of this event, for providing the brief report of the workshop. Over to you, sir, please.
Thank you, Mavan sir. Can you hear me?
Yes.
Yeah, your voice is audible.
Yes. So is my slides here? A brief report on this workshop.
Yes, sir, it's visible.
Okay. So I'll try to do as best as possible because I had to manage many things. Just summarize quickly. First, I'll say what was the objective of the workshop. So basically, let people and the student know about astronomy, astrophysics, and the difference between astrology, astronomy, and current development of astrophysics in the world, India's position and role in the current development in the astrophysics. Those are the things were there in our mind before we organized this workshop. Let me thank Founder President Sir, Chancellor Sir, VC Madam, HY Madam, HOD Sir, and our team members, because of whom we could succeed, and all others who helped us. I thank. I'm not specifically naming them. There is a vote of thanks in which we will specifically name them to thank. And in this workshop, it is a success. A lot of people actually registered, and we got, in the beginning, I saw 164 participants, and still there are about 100 listening to us. And we see the enthusiasm among the participants, and we have a plan for this kind of workshop for every year, as HY Madam was mentioning. So we have already believing in such a philosophy that we will, this will be the beginning of something. It's not the beginning and end here. And morning session, Professor Saikia gave a talk, and he mentioned about Professor Emin Saha a lot, because we are dedicating this workshop to Professor Emin Saha. There should be a professor over here. I'm sorry about it. And he nicely talked about radio galaxies and jets. And this is giant radio galaxies. He basically talked on that, and this is a recently published thing. I know, I was tracking him through Facebook and other media, and he explained nicely what radio galaxies are. And students who want to basically know about it, please follow Facebook and ask questions. Either you forward the questions to me, I'll forward the speakers, or you directly can contact them. And this is the episodic radio galaxies. So the jet phenomenon is often episodic. It is not only that just one time jet comes and it's all continue forever. It's not like that, or it comes, stops, and forever it stops. It's not like that. It's just episodic. It comes and goes. He explained that very nicely. And he also mentioned in the background what the galaxies are which host these galaxies. So this is the basic things which he covered. And then Dr. Ananda Hota, he explained two things. One is some scientific aspect. Other is he explained some organization, virtual organization called Rad at Home, which is a citizen science organizations through Facebook. He is teaching lots of sorts of students how to take the archival data and different tools or observatory tools to actually characterize various sources with those data. And then they are motivated to do science, and some of them joined PhD, and some of I know few people who have finished PhDs, and they are motivated by Ananda Hota. That is just wonderful. A lot of students are continuing to do such things, and whenever there is talk or any other things, he also invites me. I go there. I feel very happy to do that. And this is recent published works in which one jet is coming out from a galaxy and hitting other galaxy, for which the Royal Astronomical Society, London, gave a press release, and GMRT also has given press release. I'm happy to be part of the paper. And this is another discovery he made long ago, 2011, for which also he got press release. And he is the second source in which he showed that a spiral host galaxy can actually, a spiral galaxy can host a radio galaxy. And before that, there was only one, and still there was some kind of confusion whether that is one or it's a line of sight projection. But he showed that there is a second one. And after that, quickly 4 or 5 were discovered by other authors. So this had really some kind of effect. So students who are interested in that, please go ahead and learn about it and contact the author. Then Professor Pritam Kumar Das, he is from Bangladesh. We are happy that we have set a collaboration with some kind of collaborative work with Bangladesh persons, which is a neighboring country, but we hardly collaborate with them. We also have a tendency to go west. They also have a tendency to go west, and we ourselves don't talk. But this is another thing I thought in a new way. So let us do that. We're extremely happy, and let me thank Pritam Kumar Das to have some time for us. And he explained very nicely about the nuclear physics role in understanding the evolution of the universe. So we are basically stardust. He explained that, and he explained the historical aspects of the atomic physics development and nuclear physics development subsequently. And then he also explained various PP chain and CNO cycle, etc., and how the heavier elements are formed, because the universe was formed only with hydrogen and helium immediately after Big Bang, and later on heavier elements are all formed in the belly of the stars. And he explained nicely that thing. And then he also talked about dark matter, dark energy, many things he talked about. The basic things is that he clarified the role of nuclear physics in explaining the evolution of the universe. So this is the 3 morning session, then afternoon session. Professor Yasan Gupta, as I said, there is the main person in square kilometer array collaboration, and these are the things he covered in his talk. Basic astronomy, what is basic astronomy, and what he mentioned the last point, you can say, what does it take to have a career in astronomy? There is a tremendous amount of opportunity in astronomy for the engineers and the scientists who are interested in observational science, because of the scale, lots of data, tons of data will be accumulated, and they will not be analyzed by a small software like that. It will be automated, and those who are very good in coding, they can code that, and who are good in engineering, they can go and work in the building of the telescope, etc. And those who are interested in data analysis and interpretation, they can do that. Lots of data, and lots of people will be employed. It's a very big collaboration with many countries. Billions of dollars are pumped in. So students who are interested should not think what would be the career and etc. Please know about it by Googling what SCA collaboration is. Not only SCA, there is TMT, and there is LIGO, there is LISA. LIGO is in India, is a part of. Those are the things. Please try to know about it. So Professor Gupta has explained about our GMRT, and he is the founder, director of NCRA, who basically is the chief architect of the GMRT. He has expired recently, just 1 year ago probably. And he talked about square kilometer array, some details he has talked about. And how square kilometer array is pushing the next generation science and the next generation technology, that he explained very nicely. And so whatever slides I have obtained, I will pass it on to the participants, and please go through it and slowly go through it, learn it, Google it, ask questions to that. Now let me come to Professor Dipankar Bhattacharya, who talked about cosmic explosion. There are a lot of explosions taking place all over the universe, and he has listed it very nicely, all those cosmic explosions. So I'll pass it on to you, those slides which he has already sent me mail, and learn about it. Very interesting physics are there. Almost all the laboratory physics that we have learned will be all used in all astrophysical things that has been discussed today. And very exciting topics. And he also explained very nicely what powers and explosions. So he has listed it over here, and he went to much detail. I'm just summarizing it. And he has given a summary where what he has mentioned, that there is a strong Indian activity in the study of explosive phenomena. What I was talking about is K, that is also will be used to study the explosive phenomena. And he has mentioned that about strong Indian activity. So not only by SK, but other telescopes like X-ray, optical will also be used. So there is a huge opportunities. Please take it seriously, those who are interested in astro. And Professor Patrick Dasgupta, he has given a very interesting talk on first radio burst. So his first slide is actually like a summary. He has spent a lot of time explaining each and everything over here, and you can see that everything over here, how many are found, and then dispersion measure he explained, and then flux densities of those things which is detected, then the time duration, why it is called fast, what is the time duration, it will be minute, hour, or millisecond, or what it is, up to 10 to the 3 milliseconds from 0.2 to this. So this is fast compared to other phenomenon that takes place in astronomical context. Star formation, for example, it takes place in billion years time scale, but this is so fast astronomical thing. And so all these things he has explained very nicely, and he's a theoretician, a hardcore theoretician. So people who want to pursue theoretical physics, please try to keep contact with him. We'll provide you with contact numbers and emails, etc. Those who are interested, the students who are interested, really, you can meet me. And he also mentioned FRBs, whatever has been observed, are not really our galactic things; these are extragalactic. So that made it more interesting. He mentioned that. And radiation also is not thermal radiation; non-thermal radiation comes. And then radiation is coherent. He mentioned various models. He has also discussed about the first radio burst. They're really nice to know all these things. Even though we are working on, we have worked on astrophysics, still we are working, but we don't know everything. It's nice to learn all these things from various distinguished speakers who are expert in their own field. Now, Professor Suresh Chandra, last talk he has delivered, and his topic was really exciting for point of view of common people, for physicist point of view also. And because he's talking about astronomy and comparing it with astrology. And then he clearly explained, he listed it here what we could explain and what are the challenges also he has said. And then he talked about sun and solar physics, and astronomy, astrology he compared, and what astronomy says and what astrology, what astronomy does not say, what astrology say. He specifically said that astrology, to me, to many scientists, it is a pseudoscience, not a science, but astronomy is a full-fledged science. And there are people who believe in astrology. We do not take it in a different way. It is not to insult anybody or anything. But what physicists say, physics say, I'm just letting it out. And if anybody wants to discuss on that, we'll be happy to discuss on these things. And it's my pleasure. Thank you very much. It's my pleasure to give a brief report of this workshop, and hope to organize such workshop in future. And we hope a nice cooperation to all the speakers who have talked today in future such work.
Thank you very much, Professor Konar and Professor Suresh Chandra, for having me in the workshop. It was due to, I don't know why, only during my talk the internet problem occurs. I could hear everyone else's talk, but the moment I would start the talk, there'll be a problem in the internet. It's still a mystery.
So, I think, sir, that is a indication that we need you here in campus.
Yeah, good.
Yeah.
Professor,
There won't be any problem, and we are looking forward to you for a face-to-face interaction here with the students and motivate them.
I think
Thank
Suresh
you,
Chandra
thank
sir
you.
can
Thank you.
tell what celestial body is affecting, astrologically affecting.
No. I am not astrologer. I am not astrologer. Dr. Konar.
I know. I'm just joking.
No. You can joke, but I can mention that Dr. Patrick Dasgupta has been once in the campus.
Yes,
Yeah,
yes.
Yeah.
I know. I could
Yeah.
not meet him because of other
Yeah,
kind
yeah.
of duties.
Once have been, he is always very cooperative in every activity.
Thank you for your kind words, Professor Suresh Chandra. By the
Yeah,
way,
yeah.
I have been to Amity University, Gwalior.
Oh, I see. Yeah,
Yeah. They had
Yeah.
invited me to give a talk, and it was very interesting.
yeah, very good.
I hope you all are having a network with different Amity University campuses.
Yes, we do have.
Yeah.
And during lockdown, this networking increased actually.
Okay.
Because all the external examiners we were calling from other campus of IIT.
Right.
Okay, so Dr. Gagan Sharma, please carry on
Yeah.
for the rest of the.
Yes. Thank you so much, Konar sir, for enlightening the summary of event. So in a nutshell, you presented all the key points of this workshop. And now I would like to invite Dr. Vibhuti Pareda for a vote of thanks.
Okay. Thank you, Gagan sir. So, good evening to all of you. It has been an honor for me to be able to be a part of an organizing team for such an wonderful workshop. On behalf of the organizer, we would like to convey our heartfelt gratitude to the Honorable President Sir, Dr. Ashok Kumar Chauhan, the Chancellor, Dr. Atul Chauhan Sir, Vice Chancellor, Dr. W. Selvamurthy Sir, the President Astip, Professor Dr. Balbinder Shukla Ma'am, the Vice Chancellor, the Professor, the HOI Professor Dr. Sunita Rattan Ma'am, and HOD Dr. Ashok Kumar Sir, without whose encouragement, guidance, and help, this event would not have been possible. Now,
Yeah.
I would also like to thank all the faculty members of and staff of Department of Physics and other departments of AIS for their support. Heartfelt gratitude to all the speakers for their beautiful talks with huge amount of information. We also like to thank Professor Sodhi sir and his team members, Mr. Arvind Mishra sir and Mr. Kapil Sonalki sir, and other members of the IT department for providing us the online platform and constant support. I would also like to thank our contacts in colleges and universities, including all Amity campuses and outside, for giving it a wide publicity and support. It is difficult to name all of them, but I would like to thank them. Many thanks and heartfelt gratitude to our team members who are working tirelessly as panelists in this workshop. And thanks to Ritu Bhatnagar ma'am, who helped us to take our proposal quickly to VC ma'am for getting the approval. Finally, I would like to thank all the participants and students who made the event a grand success. With this, I would like to thank you all for listening this talk. Yeah. Thank you.
Thank you, Dr. Vibhuti. Now I request Konar sir to make some announcement regarding quiz. I think the
Yes.
students are waiting for it.
So workshop is over. The participants are requested to take the quiz. I'm soon putting this in the chat box. And please answer these questions. I'll tell you the time when it will be over. So before that, you should press the submit button. Whatever question you can answer before that, with that you just submit it. I have already pasted it over here. So some of the panelists, please check whether it is opening properly from your side. Gagan sir, can you just check? Gagan sir,
Yes, ma'am. Yes, sir.
can you just check whether it is opening
Just a
properly?
minute.
Yes, it's working, Dr. Konar.
Okay.
Yeah, it's working. Yeah.
Konar is, the link is
Working, right? And it is written quiz 2 when you are opening it.
Let me see.
Link is not visible.
Yes, it is quiz 2.
Okay. Yeah. Now,
So let me fix the time in the quiz. It cannot go on till indefinite time.
this link is visible.
So now I'll give it time up to 17:33. Maybe 6 o'clock. Should I give it?
Yeah, definitely.
Dr. Ashok Kumar, can I give it 6 o'clock till?
Yeah, okay, give.
Okay, so 1800 hours, I put the time.
Right.
So participants, please note that before 1800 hours, you should hit the submit button. Otherwise, you will not be able to submit it.
Kunal sir, just one request. Can you repost the link, because the students are asking in the chat box regarding
Yes,
this.
yes, twice I have done that.
So I request the students to please wait, and sir is pasting the link again.
Yes, I pasted it.
Okay.
Many times I pasted it so that those who are because of some comments it is going up and cannot see probably. So I think it is working, so we have no role. We can just close it now.
Okay, sir. Yeah.
So, sir, shall I close the session?
Yes, you can close the session now.
Yeah, wait, Dr. Chiranjeev.
Yes, yes.
Wait,
Yes, Dr. Charanjeev, we can close the session. Yeah.
Okay.
Right.
Okay,
So
thank
you very much.
congratulations to all the teams. I think
Thank you,
all, the
madam.
whole team,
Yeah.
and very good work done.
I express personally my heartfelt gratitude to you for
Sir,
taking
it's
it
a
to the
teamwork.
higher
We are a
level.
team. Yeah.
Yeah.
Taking it to the higher level to get the approval.
It is all the teamwork. We are a team working in a team,
Right.
and everyone has contributed in his her own way.
Right.
So congratulations, and I think that we'll plan one bigger one in
Yes.
physical
Yes,
world in the coming days.
So I'm happy to work in such a collaborative.
Thank you very much, ma'am.
Thank
Dr.
you, sir.
Chiranjeev,
Yes.
since we already have the permission from HY ma'am for closing the session,
Yes.
and since the link will be going through the MS Office, so you can request the IT team to close this the event, and the
Yes.
students will
So
get-
IT team is here. So he was asking me, I think.
No, the link has, I think link has been circulated.
Yes, sir. Yes, sir. Shall I close the session now?
Please close the
Please
session.
close.
Okay, sir. Thank you.
Thank you, IT team, for such
Thank
a
you, IT
wonderful support.
Thank you so
Thank
much.
you.
Ma'am.
Thank
Thank
you.
you, ma'am.
Thank you.
Thank you, Arvindji. You
Thank
have personally helped me. I went to him actually
Thank you.
to know various details.
Thank you,
Please
sir.
close the session.
Thank you, everyone.